Hey guys, in this video, I'm going to show you how to deploy a two-node Hyper-V failover cluster in Windows Server 2016 or Windows Server 2019. So what is covered in this video? Before we can actually deploy the Hyper-V role and failover cluster, we need to build a lab environment to build a single site two-node Hyper-V cluster. And for this video, I have built 6 virtual machines which will be running on top of my standalone ESXi host. Now, this type of lab requires some additional virtual machine port groups created on the ESXi host to simulate real world networking, and we are going to talk about that. After building the Hyper-V cluster nodes, there is also a requirement to create few static routes on the Hyper-V host, which will be discussed in this video. And then I will talk about networking requirements and some of the best practices that we need to follow. I will also talk about hardware requirements if your Hyper-V cluster nodes running as virtual machines or physical servers, system requirements for Hyper-V, and failover cluster requirements. We'll also talk about configuring an iSCSI target server, which will be used to provision iSCSI LUNs to the Hyper-V hosts. And these iSCSI LUNs need to be configured on the Hyper-V hosts to use them in failover cluster. After all that, we will deploy the Hyper-V role and failover cluster feature on the cluster nodes and create a cluster. Finally, we'll wrap up this video after configuring the cluster networks, storage, and quorum in failover cluster manager. So here is my lab environment with the virtual machines to build a single site two-node Hyper-V failover cluster. In my lab environment, all these virtual machines are running on a standalone ESXi host. So there is a total of 6 virtual machines which I've already built and powered on. They are DC01, Node 01, Node 02, iSCSI Target 01, Router 01, and Admin Desktop 01. Now all VMs are running Windows Server 2016 operating system except Admin Desktop 01, which is running Windows 10 client. I've already deployed an Active Directory domain called contoso.local, and DC01 is the single domain controller and the DNS server in this Active Directory domain contoso.local. It has a single NIC assigned with IP 192.168.10.1 connected to the management network. Node 01 and Node 02 will run as two-node Hyper-V servers. Each Hyper-V node has 7 NICs. NIC 1 is connected to the management network. This management network will be used for management purposes of the Windows servers, including the management of Hyper-V hosts and the virtual machines. The management network of Hyper-V hosts must have connectivity to infrastructure services such as Active Directory, DNS, and etc. In this lab demo, it can be seen where all these virtual machines are connected to a single management network. NIC 2 is connected to Heartbeat network. This is the network used by Hyper-V hosts for cluster communication, such as cluster heartbeat, used for monitoring between the hosts to detect node failures. Now, IPv6 is preferred for Heartbeat network than IPv4 since it is faster than IPv4. Although there is no requirement to specify an IPv6 address because local link IPv6 FE80 also works on this network. NIC 3 is connected to iSCSI network. This is the network used by Hyper-V host for storage traffic. The storage traffic can use either iSCSI or SMB protocol. It is recommended to use a dedicated network or VLAN and 10 gig network adapters for storage traffic. Storage network adapters must be set to lowest in the binding order if you're using binding order. It is also recommended to use multiple network adapters to allow the redundancy with MPIO. Now in this lab environment, only a single network adapter of 1 gig is being used for iSCSI network with no MPIO, which should be okay for lab purpose. If SMB storage is being used, then you need to isolate SMB storage traffic between the SMB file server and Hyper-V host by configuring SMB multi-channel constraints using PowerShell, so that you can use the dedicated network interfaces for SMB storage traffic on the Hyper-V hosts. Now, if iSCSI storage is being used, which is true in our case, we need to isolate the iSCSI storage traffic between the iSCSI target and the Hyper-V hosts using iSCSI initiator tool on the Hyper-V host to specify dedicated network interfaces on the Hyper-V hosts so that they can communicate with the iSCSI target. NIC4 is connected to Live Migration Network. This is the network used by Hyper-V host for live migrating the virtual machines from one host to another host. It is recommended to use a dedicated network or VLAN for live migration traffic and 10 gig network adapters for live migration network. Now, in this lab environment, only a single network adapter of 1 gig is being used for live migration network, which should be okay for lab purpose. Just so you know, by default, Hyper-V failover cluster can use any of the available network for live migration traffic, but you can manually select network adapters for live migration traffic using PowerShell or Failover Cluster Manager. Also, you can use multiple networks for live migration traffic. For example, you can use a migration network of 10 gig for the cluster nodes in the same site and another migration network of 1 gig for the cluster nodes in a different site. NIC5 is connected to CSV IO Redirection Network. This network will be used by a Hyper-V host which has failed storage paths or adapters to redirect all of its storage IO traffic over this network to a Hyper-V host that still has connectivity to commit the data. Now, if there is a situation of this type, then there can be a storage latency depending on the network speed of this network between the Hyper-V hosts. Now, this network is typically used if the Hyper-V host is using traditional HBA adapters for storage traffic, but it can also be used along with iSCSI or SMB type of storage traffic. Since all storage IO is forwarded via SMB 3.0, either using SMB multi-channel or SMB direct, from a host which has failed storage path to a host which still has storage connectivity, the protocols such as client for Microsoft Network and file and print sharing for Microsoft Networks need to be enabled to support SMB on these network adapters. However, no DNS registration or name resolution is required for this network. NIC6 is connected to Hyper-V Replica network. Now, this network is used by Hyper-V hosts where Hyper-V Replica feature is enabled to replicate the virtual machines from primary to replica site asynchronously. Hyper-V Replica automatically detects and uses available network interfaces to replicate the Hyper-V Replica traffic, since it is not possible to dedicate the network for Hyper-V Replica like the way we do it for live migration network. However, to designate a network for Hyper-V Replica traffic to a particular network adapter, you can use persistent routes on the Hyper-V hosts to redirect the Hyper-V Replica traffic to a specific network adapter. NIC7 is connected to VM network. This is the network that will be used by the virtual machines running on Hyper-V hosts. There can be more than one virtual machine network on a Hyper-V host, for example, production, development, UAT, and other type of networks of virtual machines. But in this lab environment, only one virtual machine network is created called VM network for simplicity purpose. Coming to the other virtual machines in this lab, there is iSCSI Target 01, which runs as iSCSI Target Server and provisions iSCSI LUNs to Hyper-V hosts. It has two NICs, NIC1 and NIC2. NIC1 is connected to the management network, and NIC2 is connected to the iSCSI network for iSCSI traffic. And there is a VM called Router01, which acts as a gateway VM for all these networks, such as management network, heartbeat network, iSCSI network, live migration network, CSV IO Redirection Network, HyperV, Replica Network, and VM Network. This router VM is installed with routing and remote access role and LAN routing feature enabled. This VM has a total of 8 NICs, each representing a network that we can see in this slide. NIC 1 connects to management network port group. The management network subnet is 192.168.10.x/24 with NIX1 IP address on this router 01 acts as the gateway address for the management network. Likewise, other NICs are connected to different port groups, and the IP addresses configured on them acts as the gateway address for the respective networks. NIC 8 of this router VM is connected to internet that has external connectivity outside of this standalone ESXi host. This is the network from where I would be connecting to this lab. All these networks are actually standard switch port groups on my standalone ESXi host with no VLAN tagging. This is just an example topology or design. This is not really a production recommended setup, but it is being used for lab purpose only. And moreover, you don't need these many network adapters on the Hyper-V host. You can simply have two 10 gig network adapters on each Hyper-V host and use VLANs to segregate different types of network traffic. You can also see these networks have different subnets. Also, I'm using additional networks such as CSV IO Redirection Network, Hyper-V Replica Network, which are not typically required for lab purpose, but I'm using them in this lab since they will be configured later in this lab environment. All the VMs are joined to the AD domain contoso.local except router 01 virtual machine, which is not required to be joined to the AD domain. Lastly, I have another virtual machine which is called admin desktop 01, which is a Windows 10 client. And this will be the virtual machine which I'll be using to deploy and manage this entire lab infrastructure. So here is the closer look at the port groups on the ESXi host. As mentioned before, all the networks that were discussed in the previous slide are virtual networks on the standalone ESXi host using virtual machine port groups and a standard switch with no physical uplinks attached. NIC 1 of all 6 virtual machines shown in the previous slide are connected to the virtual machine port group management network DC01. NIC 2 of node 01, node 02, and router 1 are connected to the virtual machine port group heartbeat network DC01. NIC 3 of node 1, node 2, and router 1, as well as NIC 2 of iSCSI target 01 are connected to the virtual machine port group iSCSI network DC01. NIC 4 of node 01, node 02, and router 01 are connected to the virtual machine port group live migration network DC01. NIC 5 of node 1, node 2, and router 01 are connected to the virtual machine port group CSV IO Redirection Network DC01. NIC 6 of the node 01, node 02, and router 01 are connected to the virtual machine port group Hyper-V Replica Network DC01. NIC 7 of node 1, node 2, and router 01 are connected to the virtual machine port group VM network DC01. NIC 8 of the router VM connected to the port group called Internet, created under a separate switch on the ESXi host, which has connectivity to external network, and it is the only port group which has physical uplinks attached for external connectivity. One thing, if you're having multiple networks configured on your Hyper-V host, it is recommended to not to configure multiple gateways on the Hyper-V cluster nodes. Instead, configure gateway address only for management network and configure static routes for all the other networks. Now, based on the NIC adapter's network type, you need to create persistent static routes for the networks mentioned in the previous slides, such as Heartbeat Network, iSCSI Network, Live Migration Network, CSV IO Redirection Network, and HyperV Replica Network. After configuring, you can see for each network there is a dedicated gateway address. For example, Heartbeat Network 192.168.11.0 has the gateway address of 192.168.11.254. Similarly, iSCSI Network 192.168.12.0 has the gateway address of 192.168.12.254. Live Migration Network 192.168.13.0 has the gateway address of 192.168.13.254. CSV IO Redirection Network 192.168.14.0 as the gateway address of 192.168.14.254. Hyper-V Replica Network 192.168.15.0 as the gateway address of 192.168.15.254. For the other network 0.0, the gateway address is 192.168.10.254, which is configured on the management network adapter of the Hyper-V hosts. Now let's talk some of the networking requirements and best practices for Hyper-V because it can become more comprehensive depending on the design of your Hyper-V topology. But here are some of the general requirements and best practices for Hyper-V networking. It is recommended to separate out the different types of network using VLANs and use two network adapters for each Hyper-V network as it provides two independent physical paths. These paths can be used for high availability purpose and aggregate throughput for a given Hyper-V network. You can simply also use two network adapters for all Hyper-V networks and segregate the networks using VLAN tagging. And you have to use 10 gig or higher speed network adapters for virtual machine networks, live migration networks, CSV IO redirection network, Hyper-V replica network, and storage network. And for all the other types of network, such as management network and heartbeat network, 1 gig NIC can be used. Use RDMA capable network adapters if possible, if you prefer enhanced network throughput, and configure only management network adapter with DNS registration, as it will ensure that Hyper-V host's hostname is registered with the IP address of management NIC in DNS. Okay, here are some of the general hardware requirements for physical Hyper-V hosts. You need a 64-bit processor and second level address translation called SLAT to install Hyper-V role on the Hyper-V host. Hardware assisted virtualization support must be turned on in the BIOS or in the UEFI. This is available in the processors. Intel calls it as Intel VT and AMD calls it as AMD V technology. Hardware enforced data execution prevention must be turned on in the BIOS or in the UEFI. For Intel systems, this is XD bit, execute disable bit. For AMD systems, this is NX bit, no execute bit. The processor should also have VM monitor mode extension enabled. This is a CPU feature that should be enabled at the BIOS level. Intel calls it as Intel VTX and AMD calls it as AMD V. Now you need to have enough memory on the Hyper-V hosts to run the virtual machines at the same time. At least 4 GB of physical memory is required for Hyper-V host itself, and more memory depending on the number of virtual machines that you're going to run on the Hyper-V hosts. And features such as discrete device assignment or shielded virtual machines requires additional hardware features to be enabled. Now, for more details on Hyper-V hardware requirement, you can use Windows Server Catalog in the Microsoft website. Now, my lab is entirely based on virtual machines running on a standalone ESXi host. And below are some of the system requirements that are required before installing Hyper-V role on virtual machine. When it comes to virtual machine requirements for Hyper-V hosts running as virtual machines, you need to enable nested virtualization on Hyper-V cluster nodes that would be running as virtual machines. In this lab, node 01 and node 02 are the two virtual machines that will be running as two Hyper-V cluster nodes. Since these are vSphere virtual machines running on an ESXi host, you need to power off these two virtual machines first to enable the nested virtualization. And after powering off the virtual machines, there are two ways to enable the nested virtualization. The first way is to edit the virtual machine settings. And under CPU section, there is an option that says expose hardware assisted virtualization to the guest OS, which needs to be enabled. The second option is to use the PowerCLI as shown in the screenshot. And if your Hyper-V cluster nodes are running as Hyper-V virtual machines, then you need to use PowerShell to enable hardware assisted virtualization on them. There are few system requirements for Hyper-V that we need to ensure before installing Hyper-V role on the cluster nodes. So it is recommended to use Windows Server 2016 and Windows Server 2019 Data Center Edition operating system on Hyper-V host because it provides unlimited VM instances that can run on these hosts, and also you can use data center features such as shielded virtual machines and storage spaces direct. You need to run Windows Update on the failover cluster nodes to make the software updates level up to date. It is also recommended to install the latest drivers and firmware on the Hyper-V cluster nodes to avoid any bugs or issues. In the case of Hyper-V nodes running as virtual machines, installing latest VMware tools on the virtual machine is good enough to ensure latest drivers are running on them. If you would like to manage these Hyper-V cluster nodes remotely using PowerShell, then you need to enable PS remoting on these cluster nodes by running the command enable PS remoting. And lastly, you have to join the Hyper-V hosts to an Active Directory domain. Now, to provide high availability to the virtual machines running on the Hyper-V nodes, failover clustering feature must be installed on the cluster nodes. However, one major requirement, whether you run failover clustering on virtual machines or physical machines, you need to ensure that the hardware configuration of the cluster nodes are same for all nodes of a failover cluster, and this includes configuration of storage, networking, and system configuration. In my case, I've deployed the failover clustering feature on virtual machines. In fact, my entire lab environment is running as virtual machines on a standalone ESXi. The failover cluster nodes, node 01 and node 02, have been or will be configured similarly from storage, networking, and system configuration perspective. So this concludes the part one of this video series where we talked about the lab environment required to set up a two-node single-site Hyper-V failover cluster, virtual machine port group configuration requirements, and then static routes that needs to be created on the Hyper-V hosts. We also discussed about networking requirements and best practices for Hyper-V hosts, hardware requirements for Hyper-V hosts for both physical machines and virtual machines, and then we talked about system requirements for Hyper-V host as well as failover cluster requirements. Now, in part two of this video series, I will talk about the configuration of an iSCSI target server and steps required to create few iSCSI disks to map them as clustered shared volumes onto Hyper-V hosts. We will also discuss about how iSCSI initiators on Hyper-V hosts can be configured to connect to the iSCSI targets to access the iSCSI disks, and how those iSCSI disks need to be formatted for using them in failover cluster.